In this video, we're going to be looking at composite functions used in a real-world setting. So, the scenario I'm going to be using is we have Bob, who's running lawnmowers. Bob has lawnmowers. That consume 2.5 gallons of gasoline each hour. Better. Gasoline costs $3.50 per gallon. I don't know what kind of gas they're buying for their lawnmower, but that's okay. So let's make up a function to represent gallons, the first sentence, the gallons that are being used by the lawnmower. So let's say G of H is the gallons the mower uses per hour. So notice it's depending on what? My hours. And if it's 2.5 gallons each hour, well, that's easy. That's going to be 2.5 times the number of hours. But what I really want to get here is what is my domain and range, what's my independent and dependent variable. The independent variable is your H, and it represents the hours. The dependent is G, and that's my gallons of gasoline. So let's talk about our domain and range as far as units. The domain are my hours, and the range are the gallons of gas. Now let's make a function that talks about the cost of the gasoline. So the next one is the cost of the gasoline. And I'm going to be creative and call that C of G, because it depends on how much gasoline you buy. And that's going to be 3.5. So $3.50 per gallon. Notice that we're depending on how many gallons of gas we cut in. So this is my independent variable. C is my dependent. My domain would be the gallons of gas. And my range is that cost in dollars. Could we create a function that figures it all out for us? So all we had to know was the hours that he was going to be mowing, and we would know our cost. Well, let's see how this is going to work. That means we'd have to start with our hours, plug them in there. That gives me my gallons, which goes into there. So hours would start off. They go into gallons per hour, and that gives me, then that answer would go into the cost per gallon. It's actually a cost per gallon, but that's based on how many hours we run. So since this is a representation for G, So let's come down here. I'm going to write this a little bit differently. Let me change this just so you can see some coloring. C of G of H. And wasn't G of H this rule? C depends on the gallons of gas. This represents the gallons of gas. So you can literally replace the G, replace this G with a function or an expression that represents G. .5 times 2.5. Our new function, C of G of H, is 8.75 times the number of hours. And let's think about our domain and range. Here we kind of had a middleman, the gallons of gas. Middleman, he's in the middle. Now, my domain are the hours, and the range, all we do is put our hours and we're getting out our cost in dollars. We don't have to go through a two-step process. We're actually only getting back, going through a one-step process. So what this actually tells me, if we really want to start digging into this, each of these coefficients of our variable were those rate of changes. This one was 2.5 gallons per hour. 3.5 was the cost per gallon, So 8.75 means I'm being charged $8.75, my cost, per hour to run the mower. Whoops, I forgot the word run. Run the mower. And although it's brief, this is an example of how you can use composite functions in a real-world setting.